Okay, guys. Hope you know where I am. If not, you'll get it later. I mean, you'll see it later. You won't get it later. So we start with some density questions that you had in homework. And I'll go through all the different possibilities of density type questions. That's seasonal allergies, folks, not COVID-19. Okay. 128A. A cube of osmium metal, 1.5 centimeters, 1.5 centimeters on the side, has a mass of 76.31 grams at 25 degrees Celsius. What is its density in grams per centimeter cubed at this temperature? So, you're just going to use the density equation straight up. Density is equal to mass over volume. Here's the mass given to 4 significant figures. Here's the volume given to 4 significant figures. Notice how I raised it to the power of 3. Why? Because they said that the cube that the osmium is composed of was 1.5 centimeters high, which means in a cube, by definition, a cube has all the sides the same length. So length times width times height gives you the volume of a cube. But in this case, length equals the width and equals the height. So in fact, you could just say L to the power of 3 is the volume. And that's what I did here. So I took the dimension of one side and I raised it to the power of 3, given that all the dimensions of the cube are the same. Again, it was also given in 4 significant figures. Here's the answer I get, 22.61037004. But I'm only allowed 4 significant figures, so I cut it off over here. And I report the answer as 22.61. So the answer also has 4 significant figures. First question solved. B. It says the density of titanium metal is 4.51 grams per centimeter cubed at 25 degrees Celsius. What mass of titanium displaces 65.8 milliliters of water at 25 degrees Celsius? Why would they mention the temperature? It's not actually used in this calculation. There's probably more than one reason why. First of all, sometimes in calculations, they'll throw in numbers that you don't need because you have to discern whether or not the number is needed in the calculation. And when you understand what you're doing, you'll be able to say, okay, I don't need to put that number in any part of the calculation. But it's also true that there are times when the temperature of something will make a difference. Metals are known to expand with heat. In fact, most substances expand with heat and contract with cold, and with the notable exception of water, which is known to expand when it freezes, which is why ice floats, because when it turns into a solid, it occupies more volume, and therefore the density of ice is slightly less than the density of liquid water. If water didn't float, it would be a disaster every time winter came because it would kill all the fish in every pond. But anyway, getting back on track, density equals mass over volume. We want to solve for mass, so I transposed the V, which is the same as saying I multiplied both sides by V, so the V's cancel, and then you get V times the density is equal to the mass. And you can also say that the mass, well, I just basically flipped it over so I can show which things I'm plugging in. I'm plugging in the density and the volume of the object, and therefore the mass is going to be 296.758, which I then report to 3 significant figures because there are only 3 figures in each one of these 2 numbers, so it makes no sense to report the answer to 6 significant figures. So that's the correct final answer. Part C now, 128C. Hope you got all of these right. And if you didn't, pay attention to what's going on here and go through it meticulously until you can understand it, and even better, if you can do it by yourself. That's how you prove to yourself that you've learned it. 128C, it says the density of benzene at 15 degrees Celsius is 0.8787 grams per milliliter. Calculate the mass of 0.15 liters of benzene at this temperature. So here's the density, and 0.15 liters times 1,000 milliliters per liter. Liters cancel, milliliters cancel, and you get a mass of 131.805. You're only allowed 4 sig figs because there's only 4 sig figs here and only 4 here. So when you report the answer, you write 131.8. 129A, to identify a liquid substance, a student determined its density using a graduated cylinder, which is basically a tall, skinny glass tube with markings on it so you can measure liquids in it carefully. She measured out a 45 milliliter sample of the substance. She then measured the mass of the sample, finding that it weighed 38.5 grams. She knew that the substance had to be either isopropyl alcohol with a density of 0.785 grams per milliliter or toluene with a density of 0.866 grams per milliliter. What are the calculated density and the probable identity of the substance? So as we know, density is equal to mass over volume. We have 38.5 grams, 45 mLs. Therefore, you get a density of 0.85, which is reasonably close to 0.866, the density of toluene. So it is probably toluene. You'll notice there's a slight error in the number. That's typical of what happens in real life, especially when you use something like a graduated cylinder, which is not a particularly accurate way of measuring volume. The most accurate way to measure volume, if it's a large amount of volume, is to use what's called a volumetric flask. And volumetric flasks have a big round bottom and then a skinny neck. And the neck is really skinny because as you start to fill it up to the last bit, the level of the liquid rises quickly, and then there's a mark that's calibrated for when the thing is at 25 degrees Celsius. So if you get it to that mark, then you know you have very close to 25, very close to whatever volume the flask is calibrated to. (29B). An experiment requires 45 grams of ethylene glycol, a liquid whose density is 1.114 grams per milliliter. Rather than weigh the sample on a balance, a chemist chooses to dispense the liquid using a graduated cylinder. What volume of the liquid should he use? Okay. So we're looking for volume now. So I've rearranged the equation so that volume is equal to mass over density. I've simply, if I was to take this version of the equation, divide both sides by density, density cancels, and get mass over density equals volume. That's what I've got here. So you have a mass of 45 grams. Here's the density of the liquid. That's how many milliliters of it you'll need. And then you'll report it through 3 significant figures because this number only has 3 figures in it. Excuse me. That's B. Now C. 129C says, a cubic piece of metal measures 5 centimeters on each edge. If the metal is nickel, whose density is 8.9 grams per centimeter cube, what is the mass of the cube? Again, remember, a cube, if they give you the length of one edge of the cube, they've already given you the dimensions of all the other edges of the cube because a cube has all edges the same length. So we're going to use density equals mass over volume. We're going to rearrange the density. Sorry, we're going to rearrange the volume by multiplying both sides with by volume. Volume cancels on this side. You isolate the mass. Here's your volume raised to the power of 3 because it's 5 centimeters by 5 centimeters by 5 centimeters. So you get 125 centimeters cubed times 8.9 grams per centimeter cubed. So the centimeter cubes cancel, and that's the mass of your cube. And you report it to only 3 significant figures because these two numbers only have 3 significant figures each. So that's why you write 1.11 times 10 to the power of 3. How did I get 10 to the power of 3? I said 1, 2, 3 to put it in scientific notation. Because I moved 3 times that way, the power goes from 10 to the 0 to 10 to the power of 3. It jumps up 3 times. The next problem is, what was that question again? Let me see, I didn't hear you. You know, you can press, I think there's a button on the bottom of the screen if you're here, and it says live chat or something, and you could probably ask questions. I've never seen it before, but if you want to try, we'll see if it works.
Anderson, office. Mr. St. Clair, contact the main office.
It'd be nice if one of you asked the questions just for fun, just to see if the thing works. Let me see, I'll press the little top chat. Some messages such as potential spam may not be visible. Live chat, all messages. Oh, we can even super chat. Okay. I don't know how to do that. I'll have to figure that out. What's this? This looks like a little magic button. No, it's just going to give me different colors. No, okay, well, I guess you'll have to write your questions and they pop up on my screen. Okay, sir, my question is, if you can do one with a calculator on example. Oh, you want me to use a calculator, do you? Okay, I'll do that. Well, let me finish this first, okay? And then we'll, yeah, one, good, I'll do that. Just wait till I'm looking at the screen before you ask a question, otherwise I won't see it. Where was I? 30A. So after the label fell off a bottle containing a clear liquid believed to be benzene, a chemist measured the density of the liquid to verify its identity. I think you can't see the chat. Who can't see the chat? Me? I could see it. If you wait to write when I'm looking at the screen, I'll see it. Maybe you have to give a few seconds for it to pop up.
Mr. Fonta, please call extension 6001. Thank you.
Huh, okay. It does work. I saw you. Okay, it works, Sneda. So after the label fell off a bottle containing a clear liquid believed to be benzene, a chemist measured the density of the liquid to verify its identity. A 25 milliliter portion of the liquid had a mass of 21.95 grams. A chemistry handbook lists the density of benzene at 15 degrees Celsius as 0.8787 grams per milliliter. Is the calculated density in agreement with the tabulated value? Okay, well, let's set it up. Density equals mass over volume. Here's the mass of the stuff you weighed out. There's the volume that was measured. You get a density of 0.878. Well, they told you in the book that it's 0.8787. So there was an extra decimal. I said close enough. I think within pretty reasonable certainty, you have the liquid you're looking for. Maybe you could do some other test. At any rate, if you're a chemist, you'd know the smell of benzene. It would be pretty obvious. 130B. Not that I'm advocating that you sniff every chemical. I'm just saying that if you're a chemist, you can't help but notice the smells of different chemicals, and it'll waft up to your nose. And it is okay to smell some chemicals if you know what you're doing. Obviously, you're not going to go and smell cyanide. It might be the last thing you do. B. An experiment requires 15 grams of cyclohexane, whose density at 25 degrees Celsius is 0.7781 grams per milliliter. What volume of cyclohexane should be used? Set it up so that we're solving for volume. So we start off with the original equation, density equals mass over volume, transpose the V, then transpose the rho, you get this. Then enter the values, 15 grams mass, there's your density, you get an answer of 19.2777278. You're only allowed 3 sig figs. You have 4 sig figs here, but you're only allowed 3 because of that. So you report the answer as 19.3. You notice you cut it off there. The next number is 7, so what do? I round it up. I round it up to 19.3. So that's what I report as my final answer. 130C. A spherical ball of lead has a diameter of 5 centimeters. What is the mass of the sphere if lead has a density of 11.34 grams per centimeter cubed? Remember, the volume of a sphere is 4 over 3 pi r cubed. In this case, what I did is I said, okay, the diameter is 5 centimeters, which means the radius is going to be half of that, or 2.5. We know that the volume of the sphere is 4 over 3 pi r cubed, so that means I can take that 2.5 and plug it into the formula, raise it to the power of 3, because it's 4 over 3 pi r cubed. You cube both the unit and the number and the unit. The number you get when you enter that into your calculator, somebody wanted me to use a calculator. Here we go. Try to give you a close-up. 2.5 2.5, I've entered it in my calculator, and then I raised to the power of 3. You see, you press second function, in my calculator anyway, and there's the x to the 3 power. So I press that, boom, and I get this. And that equals, so it raises 2.5 to the power of 3, and then I press equals, and it gives me the answer. But I'm not finished. I still have to multiply by pi and by 4, and then divide by 3. So times pi times 4 divided 3 equals. I'm trying to get it out of the glare. And what you get is 20 and 5/6 pi, which doesn't look like anything I have on the board. But here there's a button. You see that button here? It says change. If you press that button, it gives you different versions of the answer. It gives you with the fraction, gives you as an improper fraction, and then it gives it to you as a decimal. And there it is. If you look at it as a decimal, it's 6.544984669. I see it reversed. I hope you see it right. And there you can see that I've got the answer already written up on the board. Okay, so you got to play with your calculators and get familiar with them, because you don't want to be getting familiar with them when you're in a test. That's why I say get these things. Eh? Look at the one I've got. It's got the EL. Focus. Anyway, it's ELW516XG. It's about 35 bucks. You're worth it. So then put the density times the volume. That's what you're doing here. Here's the density. Here's the volume. You get 742. You're only allowed to report it to 2 significant figures. But when you continue your calculation, don't use that number to continue the calculation. Use the unrounded number. Otherwise, you'll introduce what's called rounding error. Oh, we're finished. Okay, there's your mass. The mass is 740 grams. Then 131A. This is the challenge question. I found this one moderately challenging, and I'll explain how you get around it. So here, I'll read you the question first. The question is, gold can be hammered into extremely thin sheets called gold leaf. Go figure. If a 200 milligram piece of gold, density of 19.32 grams per centimeter cubed, is hammered into a sheet measuring 2.4 by 1 foot, what is the average thickness of the sheet in meters? So you're hammering a piece of gold into a very flat sheet. But a sheet is essentially a rectangular prism. A rectangular prism has length, it's got width, and it's got height. In this case, you have a very skinny rectangular prism because it's the height is very little, but the length and the width is considerable. It's 1 foot by 2.4 feet. So the first thing I did is I found the area of the sheet. So I'm finding out the length times the width. That's why I multiply 1 foot by 2.4 feet, and then I multiply by 12 inches per foot, but then squared it because I'm converting the area, and multiply by 2.54 over inches to find the area in centimeters. So I found the area of the sheet in centimeters. No, this is not cubed, it's squared. I put the wrong, oh boy. Nobody noticed in the last class. Okay, this is squared. Oh, the power was correct. Silly me. Was it a 3? Yeah. Yeah, it's a square. It's an area, so it's centimeters squared. So actually I was okay. I was looking at the wrong place. And so I found the area of the rectangular prism. Now, if you know the area of a rectangular prism, and you divide it by the volume of the rectangular prism, you're going to get the height. Because remember, the volume of a rectangular prism is length times width times height. Okay, so if you know, that gives you the volume. Length times width times height gives you the volume, but the area is only length times width. So if you divide length times width times height by length times width, what you're left with is height. And that's what we did here. So the height of our rectangular prism made of gold is the volume of the thing divided the area of it. And this is the height we get in centimeters. So then what do? I converted centimeters into meters by dividing by 100. That allows me to cancel centimeters. And then I multiplied by 10 to the power of 9 to turn it back into nanometers. And the final answer I get is 46 nanometers. So 46 billionths of a meter thick. That's why gold can be hammered so thin that you can actually eat it. People actually put it on cakes as a decoration, and the amount of gold is so little, and gold is so unreactive that you can literally eat it and it's not toxic because it does not form compounds with anything in your body. So you just excrete it after. There are compounds of gold though that you can take. I know there's gold drugs. There's a drug, you can even look it up. It's called Oranophine, and it's a drug used for the treatment of arthritis. I don't know how effective it is, but it was used experimentally at some point. Anyhow, that's it for the live stream, and I'm going to record the next part on a pre-record, and I'll put it online for you soon. So I'm going to be sitting on my computer for the next few minutes putting all this stuff online. This hopefully will go will upload in the next 24 hours or less. Yeah, last time it did it in a matter of about 12 hours. So I hope you guys start attending class. You're supposed to be attending class. I see the numbers never go higher than about 4. And I'm not even sure if it's my students. I saw a couple names I recognize, but it'd be nice if you all came together. It's kind of fun too to watch from home. Okay? You can get your parents to watch it too, and then you can all learn chemistry together. Make it a family affair. I'll see you later.